Hello students. Today we came up to the next session of electrolysis topic. So we can say it's volume 2, right? In volume 1 we have seen theory of electrolytic dissociation. Now in volume 2 we are going to see electrochemical series, a series which has a very important role to determine the electrolytic reactions. Electrochemical series. It is actually a series of ions, or we can say it's a series of cations and anions. Like in junior classes, like in your class 8th and class 9, you people have studied metal activity series, which in senior classes also we have. But over there we have seen about the reactivity of the metals or the reactivity of non-metals. But this electrochemical series which we have over here is actually the series of the charged particles. It's a series of charged particles, cations and anions. Okay? This series can also be termed as standard electrode potential, or this series can also be termed as standard reduction potential series. Now, what's the meaning of this? Potential means strength. Now, how much electrode has a strength to discharge the ion which is attracted towards it? That we can determine on the basis of this series. On the other hand, we can say how much strength an ion shows at respective electrode in order to get discharge. For example, if we compare the two metals, magnesium and zinc. Okay, now see, magnesium metal has more reactivity than zinc. It can form magnesium ions with the loss of 2 electrons. The loss of 2 electrons means it gets oxidized, or we can say acts as an reducing agent. Similarly, if we say magnesium ions, now it's a charged particle. Now we're talking about charge for the electrochemical series, so we have to focus about this thing. Okay. So if magnesium ion is taken, then the magnesium ion will be gaining 2 electrons, to form magnesium metal. If it gains 2 electrons, that means it is getting reduced. Gain of electron is reduction. It is getting reduced. Reduced, or we can say acts as an what? The one which gets reduced acts as an oxidizing agent. Acts as an oxidizing agent. Check. Similarly, if we take it zinc will also lose 2 electrons and form Zn plus 2 ions, which is oxidation, or we can say it's a reducing agent. Okay, I'm just writing in short. Similarly, if I take it zinc ion, it is going to gain 2 electrons and form zinc metal, which means it is getting reduced, or it's an oxidizing agent. ठीक, फाइन, बिल्कुल सही है यहां पर. अब इन दोनों को कंपेयर करिए. Magnesium reactivity is more than zinc. And you can see that in this, on the basis of this reactivity, we can say zinc tendency to lose electrons will be less as compared to the magnesium electron losing tendency, because its reactivity is less. So we can say it is not a good reducing agent as compared to magnesium, because zinc electron losing tendency is less than the magnesium because its reactivity is less. So if the electron losing tendency is less, so we can say its reducing nature. Its reducing nature is less than what? Magnesium. Because it is not easily giving out electron. As it is not easily giving out electron, it won't be helping the other particle to get easily reduced. Okay? Now, if it is not a better reducing agent, then in that case, zinc ion, which is getting changed to zinc by taking electron, will it be a good oxidizing agent? See over here for the magnesium. Magnesium ion is gaining electron and getting reduced and acting as an oxidizing agent. So if magnesium is easily losing out electron, there is no condition over there under which magnesium ion can gain electron easily. Means it is not a good oxidizing agent. Magnesium ion won't be taking electron easily. Why? Because magnesium metal was having a tendency to lose electron easily. So its ion won't be having a easiness to gain the electrons. So in that way, it won't be acting as a good oxidizing agent. But on the other hand, zinc cannot lose electron because its reactivity is less. It cannot easily lose electron. So its zinc ion will be easily taking electron, and when it is easily taking up electron, its oxidizing nature will be better than what? Magnesium. यानी कि ये ज़्यादा easily electron लेगा. अगर ये लेगा तो zinc will be having more discharging tendency than magnesium. And this is what the electrochemical series is all about. That while moving down in the series, discharging tendency of the ions increases. Discharging tendency of ions increases. This is what the overall electrochemical series is. I hope with this example it is very much clear. जो मेटल इलेक्ट्रॉन इजीली लूज करता है उसका आयन उतना इजीली इलेक्ट्रॉन गेन करके डिस्चार्ज नहीं हो सकता. जो मेटल जितना इजीली इलेक्ट्रॉन लूज नहीं कर पा रहा है वो उतना ही इजीली इलेक्ट्रॉन गेन करके डिस्चार्ज कर जाएगा. उसका आयन उतना ही इजीली इलेक्ट्रॉन गेन करके डिस्चार्ज कर जाएगा. यानी कि अगर हमने दो मेटल लिए हैं, metal 1 and metal 2, if this metal is highly active than this one, तो इसका ion easily discharge नहीं होगा at the electrode. This is what the standard electrode potential means. The strength of the electrode, how easily it is helping the ion to get discharged over there or not. Okay, clear? Now, we are taking up this series, and with the help of this series, we're going to see that how in the different electrolytic reactions, the series is useful. According to class 10th, is electrolysis of acidified water. I'm picking up that. Now, why water is going to form respective ions? Which ions are going to help in that, which ions will be coming up, why pure water cannot be taken for electrolysis, all that is that part I'm not discussing right now. Okay, that I'll be able to take it in a different case, in a different video maybe, but right now I'm focusing that whatever the ions are produced, which out of those will be getting discharged. Okay, so we are taking acidified water. Acidified water will be giving out H plus and OH minus ions. This is acidified by the help of dilute sulfuric acid. शॉर्ट में समझ लो क्यों, क्योंकि नॉन वॉलेटाइल स्ट्रॉन्ग एसिड होता है, तो नॉन वॉलेटाइल की वजह से इसकी फ्यूम्स इवॉल्व नहीं होती हैं और जिसकी वजह से जो प्रोडक्ट हमारा H2 और O2 गैसेस मिलती हैं वो प्योर फॉर्म में मिलते हैं, इम्प्योर नहीं मिलते हैं. अभी इन शॉर्ट इतना समझ लो. ठीक है, जब हमने सल्फ्यूरिक एसिड लिया है तो सल्फ्यूरिक एसिड भी बीइंग पोलर आयनाइज करेगा और ये प्रोड्यूस करेगा H plus and HSO4 minus ions, and the HSO4 minus ions will further gives H plus and SO4 minus 2 ions. ये हमारे total ions है. So total positive ions we have only one type, H plus, and the total negative ions we have two, that is hydroxyl and sulfate. अब देखो, in the previous video, that is electrolysis volume 1, if I say, the previous one which I uploaded, अगर आप लोगों को नहीं पता है, नहीं देखा है, तो आप लोग देख सकते हैं, that is on my channel Chemistry by Paul Sir, where I have explained the theory of electrolytic dissociation. So there it is clearly mentioned over there, you can see about that video. Now over here what we have between the two ions, that one is going to get discharged which is having more concentration. There we have discussed that more concentration helps the ions in order to conduct the electricity. Okay? Now we have taken water, we have taken acid. Both the particles, both the compounds, ions over here, they are in sufficient amount. तो इसका मतलब सारे के सारे discharge होंगे? No. What? See. कैथोड पे नेगेटिव है तो कौन जाएगा? ऑफ कोर्स पॉजिटिव आयन. पॉजिटिव आयन वी हैव ओनली वन इन द मीडियम, दैट इज H plus, will be gaining up electrons and forming H atom. H is not stable in its monatomic state, so it will combine with another H atom in that medium only and will get changed to a stable molecular state, H2. Anode. At anode, what will move? OH minus, SO4 minus 2. अब अगर आप यहां पे देखें anions की series, I have made over here anion series. The most electronegative is coming first as F minus ions. और अगर ये most electronegative है, tendency to attract electron सबसे ज्यादा होता फ्लोरीन में, तो इसके आयन में डिस्चार्ज होने की टेंडेंसी बिल्कुल नील होती है. उसी तरीके जैसे जैसे हम नीचे मूव करते चले जाते हैं, डिस्चार्जिंग टेंडेंसी क्या हो रही है? धीरे धीरे बढ़ने लगती है. ऊपर वाले की कम, उसके नीचे थोड़ी का और ज्यादा, उसके नीचे थोड़ी और ज्यादा बढ़ती जाएगी. सो इफ यू कंपेयर दीज टू, दैट इज सल्फेट एंड OH minus, which one is going to have more discharging tendency? From the electrochemical series, it is very clear that OH minus ion will be discharging faster as compared to sulfate. In fact, sulfate discharge हो भी नहीं पाता है. ठीक है, कई एग्जाम्पल आप देखोगे. तो यहाँ पे एनोड पे हमारा ये दोनों गए, पर दोनों में डिस्चार्ज कौन होगा? जिसका कंसंट्रेशन ज्यादा, नंबर वन. कंसंट्रेशन हम मान के चल रहे हैं दोनों के ठीक ठाक हैं, सफिशिएंट है. तो नंबर टू हम क्या देखेंगे कि इन दोनों में किसकी डिस्चार्जिंग टेंडेंसी ज्यादा है. तो किसकी ज्यादा है? सल्फेट की कि OH माइनस की? OH minus. So OH minus will be losing one electron and forming OH radical. OH radical will combine with its own OH minus ion. OH radical, will be combining with its own kind and forms 2H2O and O2, for which this should be coming up 4OH. ये हमारी रिएक्शन आती है when the hydroxyl ion gets stable, it forms water and O2. अब अगर हम यहाँ पे देखें तो सल्फेट आयंस मीडियम में थे पर वो डिस्चार्ज नहीं हुए. क्यों नहीं हुए भाई? क्योंकि उनका क्या है? इलेक्ट्रॉन लूज करना यहाँ पे. तो यहाँ पे क्या हुआ? उनका जो इलेक्ट्रोकेमिकल सीरीज में उनके जो डिस्चार्जिंग टेंडेंसी थी, जो उनकी डिस्चार्जिंग टेंडेंसी थी, वो क्या थी? कम थी. इसलिए उनसे पहले वो डिस्चार्ज होगा जो सफिशिएंट अमाउंट में है और प्लस उसकी क्या है? डिस्चार्जिंग टेंडेंसी भी ज्यादा.